Here's your quick recap on hybrid orbitals. So hybrid orbitals are how we actually have Vesper structures. But at this point, that doesn't really matter to you. Okay, so I want to show you, talk about these two structures first. So let's hit this first one on the left. When I look at this structure on the left, I can see it's all single bonds. So what I'm looking at right here is this is carbon. This is a normal carbon atom. And his his electron configuration is 1s2, 2s2, 2p2. And so what we're going to do is actually hybridize them. That means he takes this electron and he shoots it up into here. Boop. And then he takes all of these boxes and smashes them together. When I say the word hybrid, you're probably thinking of, well, a hybrid is taking this thing and smashing them together. That's exactly what a hybrid orbital is. I know that I have 1, 2, 3, 4 bonds around carbon, so I'm going to take 1, 2, 3, 4 boxes. I'm going to smash those 4 boxes together. 1, 2, 3. See how I made 4 boxes? And this is actually called sp3. So I took 1 s and 3 p boxes, and I smashed them together to make sp3. What that means is I made a new shape. So hybridizing is taking things and smashing them together. The S shape is a circle, and the P shape, there's 3 different kinds of P shapes, is this dumbbell kind of shape. So what I did is I actually took all these shapes, the S and 3 P's, and smashed them together, and it actually makes a tetrahedral shape. Tetrahedral shape is what our Vesper structure is. So the hybrid orbitals create these new shapes, and the new shapes are what the Vesper structures are. Going back to our picture here, I have 1, 2, 3, 4 electrons, so I'll put them here. And these are the 4 electrons that are actually living up here, like this electron in the carbon is doing to the hydrogen. This electron to this carbon is this hydrogen, and another hydrogen, and this is the carbon bond. So what all these boxes are the different bonds to different parts. That's the basic idea of what hybrid is. What do you really need to know? What you really need to know about all of this is what I'm going to do next. You just have to decide what kind of hybrid orbital it is. In other words, tell me what this is. I look at carbon and I see he has 1, 2, 3. 3 things around him. So I would call him sp2. 1 s, 2 p's. You add that together, you get 3 things. 3 things around carbon. I'm going to keep going here. I look around the oxygen and I see he has 1, 2, 3, 4 things around him. You count lone pairs also. So I call he's sp3. 1 s and 3 p's makes 4 things around him. This one here I've got 1, 2, 3, 4. 4 things around him, sp3. Looking at this nitrogen, he has 1, 2, 3. 3 things around him. I know he's got a double bond, but that doesn't matter. It's about the things around him. 1, 2, 3. This would be sp2. 1 s and 2 p's add up to 3. So that's the first skill you need to know with this sort of thing. And then the other thing is vocab terms about pi and sigma bonds. This is a sigma bond, and this is pi bond. A sigma bond is any of your single bonds. So there's a single bond right here. This is a sigma bond, sigma, sigma, sigma. And the first bond you made here is called a sigma bond. So this one has 5 sigma bonds, and a 1 is a pi bond. 1 pi bond. A pi bond is any of your double or triple bonds. So over on this part here, I have 1, 2, 3, 4, 5, 6, 7. 7 total bonds, and they're all single bonds, so they're called 7 sigma bonds. Going over to water, he has 2 sigma bonds. Going over this nitrogen here, he has 3 sigma bonds. Going over to this guy here, he has 1, 2, 3, 3 sigma bonds, and 1 is a double bond, so I'd say 1 pi bond. Those are the 2 things you really need to know about hybrid orbitals. That's my quick summary. As long as you've got number of pi bonds and can do S or sp2 or sp3, you're good.